Hello friends, today we will going to see parametric equation of line, which is also known as Cyrus beck algorithm, and it is also known as Liang Barskey algorithm. So here we go. Here's a line and we have mentioned 2 points whose coordinate is x1 y1 and x2 y2, and here t, that is at starting point, t is equals to 0, and here at ending point t is equals to 1, which is basically the time. Okay, here is the parametric equation of line. X is equals to x1 plus t delta x and y is equals to y1 plus t delta y. This is basically the parametric equation of line. So now if we want to clip any line, so what happens is, what is actually clipping? Like this is our clipping window. Okay, this is our clipping window and this is a line we want to clip. This is a line we want to clip. The coordinates are P1 and P2. Fine. So what is actually clipping? We are going to eliminate this portion which is lying outside the clipping window, and we will reach its intersection where it is intersecting the edge of that polygon, and we will now going to label that point as P1 dash. So this is our clipped line. This is our clipped line. Okay, now through this algorithm we basically have to judge whether the line lies inside the window, whether it lies completely outside the window, or whether it lies partially inside the window. So 3 cases are there. Fine. If we want to see that whether actually a line which we need to clip, a line to be in window, particularly in a window, what should be the basic condition for that? Like if we take our coordinate plane and here is our window and this is our line whose coordinate is P1 and P2 are 2 points. Okay, fine. Starting and ending point, this is our window. So this will be our XW minimum, window का x coordinate, उसका minimum edge. This will be XW maximum. This will be this portion, I must say, this will be YW minimum, and this portion will be YW maximum. Right? You can have a look at it. Right, so any line to be inside this clipping window should follow certain condition, and what are that conditions we are going to look. Now here we can see that for a point x to be in the window, this condition should be followed. XW minimum is less than equals to x is less than equals to XW maximum, and for y coordinate to be inside that window, YW minimum is less than equals to y is less than equals to YW maximum. Fine. Now earlier we have mentioned this values of x and y. X is equals to x1 plus t delta x and y is equals to y1 plus t delta y. Now we are going to put the values of x and y here. X1 plus t delta x, y1 plus t delta y. Fine. Now we are going to separate these equations. X1 plus t delta x is greater than equals to xw minimum. According to this equations, upper equations, we have written all these 4 equations. X1 plus t delta x is less than equals to xw maximum. Y1 plus t delta y is greater than equals to YW minimum, and y1 plus t delta y is less than equals to YW maximum. Fine. Now we will find, after finding all this, after separating this equation, we will find t delta x. So we will shift this x1 here, तो ये minus में आ जाएगा. Similarly, like we have done here, t delta x is greater than equals to xw minimum minus x1, and similarly we do it for all. T delta x is less than equals to xw maximum minus x1. T delta y is greater than equals to YW minimum minus y1. T delta y is less than equals to YW maximum minus y1. Right? सो नाउ अब हम सबको लेस देन इक्वल्स टू के इक्वेशन में चेंज कर देंगे. फॉर दैट वी नीड टू मल्टीप्लाई दिस विद माइनस, बोथ द साइड्स विद माइनस, सो द साइन विल चेंज. सो हेयर वी हैव चेंज द साइन बाय मल्टीप्लाइंग बोथ साइड माइनस, ताकि जो साइन है, जो सारी इक्वेशंस हैं, वो लेस देन इक्वल्स टू की फॉर्म में आ जाए. सो यू कैन सी दैट. ओके, 1 2 3 4 इक्वेशंस आर देयर. अब हम देख रहे हैं कि ये बेसिकली एक फॉर्मूला बन रहा है. एक जर्नल फॉर्मूला अगर हम इसके लिए बनाएं तो टी पी एक्स इज लेस देन इक्वल्स टू क्यू के, सॉरी टी पी के इज लेस देन इक्वल्स टू क्यू के, वेर के कैन बी एनीथिंग 1 2 3 4 एंड सो ऑन. इट कैन बी एनीथिंग. ओके, लाइक if we talk about the first equation, if k is equals to 1, then pk would be what? Minus delta x, and qk will be x1 minus xw minimum. Fine. If 2 हो जाएगा k, तो हो जाएगा हमारा pk will be delta x, and what will be our qk? xw maximum minus x1, right? xw maximum minus x1. So if our k is 3, so pk will be minus delta y, and qk will be y1 minus yw minimum. And if our pk k value is 4, then what will be our pk? That will be delta y, and qk will be yw maximum minus y1. So like this I've written here. Like similarly we can calculate. Fine. Now using these values we will identify whether the line lies inside the window, or it lies outside the window, or it lies partially inside. Fine. So we have an algo for that. It has some points. First we need to identify the points, endpoints, that is x1 y1 and x2 y2. Then we need to find delta x, delta y, and p1 p2 p3 p4 q1 q2 q3 and q4. and assign करेंगे हम t1 को 0 and t2 को 1, because starting point पे t is equals to 0 and ending पे t2 is equals to 1. अब हम चेक करेंगे whether the line lies inside, outside or partially inside. For that we have certain conditions. If pk is equals to 0, if pk is equals to 0, the line lie inside the window. Fine. अगर pk 0 हो जाएगा तो लाइन जो है हमारी लाइन लाई करेगी inside the window and it is parallel to the window. अगर qk less than 0 हो जाएगा तो लाइन लाई करेगी outside the window. अगर pk हमारा not equals to 0 होगा, अगर pk 0 है तो फिर inside लाई करेगी. अगर pk 0 नहीं है तो या तो pk less than 0 होगा या फिर pk greater than 0 होगा, है ना. अगर pk लेस देन 0 है तो हम फाइंड करेंगे t1, दैट इज इक्वल्स टू मैक्सिमम ऑफ qk 0, मैक्सिमम ऑफ 0 qk अपॉन में pk. एल्स pk ग्रेटर देन 0 है तो हम t2 फाइंड करेंगे, विच इज़ मिनिमम ऑफ 1 ऑफ qk बाई pk. और अगर हमारा जो है t1 ग्रेटर हो गया t2 से, हमने जो फाइंड किया उसके बाद t1 अगर ग्रेटर हो जाता है हमारा t2 से, तो हम बोलेंगे लाइन जो है इट लाइज आउटसाइड. एल्स आइडेंटिफाई न्यू एक्स वाई, या फिर हम न्यू एक्स वाई आइडेंटिफाई करेंगे अगर हमारी जो है t1 t2 चेंज हो जाते हैं तो. ओके, आई होप यू गाइस आर क्लियर विद इट. थैंक यू फॉर लिसनिंग.